Good morning, good evening, good afternoon. Hope everyone is doing well and ready to learn tonight. And damn it. Hang on one second. Great start. Tonight we get into the quantum realm. We moved Science and Tech Tuesday to Wednesday, so I can be joined by a good friend of mine, Mr. Brian. He will be joining me shortly. I hear myself. Why do I hear myself? Boomer. There, I called myself, so you can't make fun of me for it. So let's say hi to everybody, and we'll get into it. Brian, I believe, is joining us around 9 o'clock Eastern. So we'll get started with the book, and then we'll get into the rest of it. Hey, what's up, Corn Pope? Devel, what's up, man? The wonderful Impish. Yes, please do that. I'm bleeding subs again, per usual. And I would really like to not. I'd like to go the other way. So please go hit that like, subscribe. If you're not, check to make sure you still are. What's up, 3 beers? As you saw in my message, your words no longer hurt me. Kind of, they do. But I'm not going to tell you that because that would be weird. No, I didn't. Well, that's good. You can take them off, though. Like, take the extra second and do it right. What's up, Sleazy? Dazer, good to see you, buddy. Holy shit, Mighty Meat is in the chat. Like, he's a good bloke. Let's keep going, Dazer. Hey, Barb, good to see you. Yes, please. It's still engagement, brother. Like, I'm good either way. Let's go over and take a peek at the rumbles. And it's impish because nobody talks over here. If you're on Rumble, they fix their chat. Send me a chat. Send me a chat so I can know you're over there. I like to engage and interact with people. So don't be a stranger. Send me a chat. Sorry, I know this is terribly slow. Big news. Just finished the deck, so I was doing it while I was chit-chatting. Looks nice. Well, I finished part 1 of the deck, so that's great. I got the decking on the deck, so next will be the gate, railing, couple different things that I gotta add, but stairs, all that good stuff, piece by piece, little by little, when I have 5 minutes. Anyways, let's get into it, guys. So, as usual, I'm reading from the book. Yes, fake wood. Rubber wood. So we're going to start into the quantum world. The quantum world is very interesting. It doesn't seem to obey any other rules or laws, and it gets really freaky. We're going to do a couple different chapters or a couple different shows on the quantum world. Brian and I went back and forth on planning to see if you're like, I adore you. Oh, Trump Jr. What's up, Jude? And I appreciate it, Barb. Semen after, rubber wood before. I truly do appreciate it, Barb. But if you want, you can go over and watch. He's not going to be on there probably the whole time. Maybe he is. Shit. Maybe I just sent you away and I probably shouldn't have. Please stay. Anyways. So Brian and I went back and forth. The uncertainty principle and quantum mechanics, they kind of are one and another. One completely counteracts what I'm about to teach you at this one. So just take that with a grain of salt. Quantum mechanics the quantum realm, the quantum world is very confusing. So I'm going to try and simplify it as much as possible and give you guys a brief overview. We've kind of laid the foundation, if you're a regular here, of different things to get us to this point. So this is where famous experiments such as Schrodinger's cat come in, quantum field theory, quantum fluctuations, quantum entanglements, and then grand unification. So this is kind of the start of a further subject, and I promise it'll go more interesting after we get done with the book and Brian gets here. But so our 30-second theory out of my lovely book here. This is the weird yet incredibly powerful theory of the subatomic world, in which everyday concepts to do with forces and motion no longer apply in the same way. Instead, we need a new kind of mechanics based on what are called quantum rules. The idea was first developed in the early 20th century by German physicist Max Planck, which some of you may know, who proposed that energy comes from tiny lumps called quanta. The theory was extended by Albert Einstein, Niels Bohr, Paul Dirac, and Werner Heisenberg, among several others, in the 1920s. So that is Schrodinger's cat. Jude Schrodinger. The cat's both alive and dead at the same time. We'll get into that in a later chapter. However, despite its tremendous success, quantum mechanics remains shrouded in mystery because, uniquely among scientific theories, no one really knows how or why it works. It makes certain predictions about the microscopic world that go completely against our common sense. For instance, it explains how an atom can exist in more than one place at the same time until we check to see what's up with it. It also says that the electron can spin both clockwise and counterclockwise at the same time until we measure it. Oh, no, you're fine, Jude. These and many more strange properties are not created by problems with the theory, but are simply, or not so simply, depending on your point of view, how nature behaves down at this scale. And as I said, the related theories are the uncertainty principle, Schrodinger's cat, and quantum field theory. Our key people are Max Planck, Albert Einstein, Niels Bohr, Heisenberg, and Dirac. And this is really, we found the God particle, we can't do quantum. Well, God particle wasn't really what we, we found the particle, it just wasn't. There are smaller units that make up the God particle. So we thought it was the basement floor, but there's one more level, at least. This is what really drove Albert Einstein crazy. Absolutely crazy. It's what held up his grand unification theory. And really what voided his entire life's work, because he couldn't have a unified theory. 30-second text. Quantum mechanics does not give a simple answer, or blah, blah. Quantum mechanics does not give simple answers. For instance, predicting that the same subatomic particle can exist in a host of different states at the same time. So we'll get into the thrash and the thought, and then we'll go a little deeper. As one of our founding fathers of quantum theory, Niels Bohr, once said, "If you are not astonished by quantum mechanics, then you haven't understood it." So the more you understand, the weirder it gets. 3-minute thought. Quantum mechanics is probably the single most important theory in physics, despite the difficulty we have in understanding what it all means. We have it to thank for almost all of modern technology. It describes how atoms stick together into molecules, how semiconductors work, and explains how laser functions. Without the quantum mechanics, we would have no computers, MP3s, cell phones, or life-saving medical treatments, and so much more. So, quantum mechanics is one of those fundamental theories, or fundamental ways in which we do many things. It's a big, scary development that says, whenever you say it, people are, "Oh my God, it's quantum mechanics." It's really more interesting than anything. So I know we watched this video before, but we're gonna hang on. We're gonna watch it again, and because I was hesitant at first. Basically, what this theory says is that when we observe something, it changes. That's one of the things. And also that when something is there, it could be in every position at once. For a minute, because I can't actually physically do a double slit. I guess I could, but so I'll use. Come on. So another thing is that particles can be in every position, and it's really quite insane. Hey, Mystic. Like I said, Brian will be here in a minute, so I think this guy does a great job. The Royal Institution. And we'll kind of break it down and expound upon what he's saying, but okay, so
I'm going to explain to you what's known as the central mystery of quantum mechanics. It was Richard Feynman, the American physicist, said, this is the central mystery of quantum mechanics. There's lots of weird stuff that goes on in the quantum world. Hit you with this, and it basically tells you what it's all about. It's called the two-slit experiment. I'll start with this. Imagine you have a source of light shining against a screen with two slits. Now, for the pedants in the audience, this source of light has to be monochromatic light of a particular wavelength, whereas, of course, a light bulb is white light, and that's made up of all the colors of the spectrum, lots of different wavelengths. But imagine this is just a single wavelength of light, and you can see the light is coming out in waves like ripples in a pond.
And when this experiment was done, it was really confusing. So you have the waves that are propagating. So you have the light going through, waves that are propagating, and then you collect it in a very distinct pattern, a distinct and repeatable pattern. And this is the result of the light bouncing off these slits and going to its respective place. So it's essentially propagating the waves. Here is where it's going. Yes, send it through and it gets particles and waves.
The nature of wave-like behavior. As the light hits the screen, it squeezes through the two slits, and each slit in turn on the other side becomes almost like a new source of light, and the light spreads out, it diffracts.
Yep.
And as the waves of light overlap, they will interfere with each other. So where a crest hits a trough, they will cancel. Where a crest hits a crest, they will amplify, and so on. And so on the back screen, you end up with what's called an interference pattern, a series of light and dark fringes, where the waves have either cancelled out or worked together in phase. That's fine. That's not quantum mechanics. That's a property of light that goes back over 200 years that we've known about since the early 19th century. Imagine doing the same experiment again, but doing it not with waves, but with particles. Do it with grains of sand. So this is the same experiment, but I've tipped it 90 degrees. Rather than waves that are spread out that wash up against the two slits and squeeze through, here you've got individual particles of sand, and each particle will either go through one slit or the other. And so you see they will sort of drain through, and you get two bumps under.
And this is interesting because what he's going to get to eventually, and what's fundamentally groundbreaking about this is it seems like our observation, well, not seems like, our observing the actual act changes where these particles interact. So we're illustrating it with sand and light because particles are very hard to isolate. But so he's going to illustrate it with sand, so it makes a little bit more sense.
Underneath each of the slits. So the two peaks is reminiscent of particle-like behavior, whereas the multiple pattern of interference is wave-like behavior. What if we do the same experiment with atoms? Well, so imagine we have an atom gun, something can fire atoms, a stream of atoms. You can't see them because they're very small. Let's block off one of the two slits. So these two slits are the dimensions and separation of the slits is chosen appropriately to show us how atoms do things.
All right, Bob.
And so far, so good. Nothing strange here. You'll see a lot of atoms hitting the back screen. So this will now have to be some sort of photosensitive screen whereby when an atom hits it, it'll give off a little flash of light to say the atom has arrived here. So the atoms are arriving as these little pinpricks of light that we see.
And I can't recreate that, or I would. I could, but it would be a pain.
Of course, a lot of the atoms will be blocked by the first screen. They won't go through that slit. But those that do get through to the other side, you can see there's a bit of spreading of the atoms. But if we didn't know anything about atoms, say, well, that's fine, we can understand that. A lot of the atoms are going clean through the slit. Some are sort of maybe bouncing off the edge of the slit, and so they're sort of being deflected a bit, which is why you get a bit of a spread. The first mystery of quantum mechanics comes when we open
what's up, Mike?
The second slit.
I agree.
No flip, no cap, no mess. Just grab and squeeze. Try Dawn Easy Squeeze.
Easy squeeze. So YouTube's getting worse with their ads.
Build custom industrial machines.
Because now we see something that's very much like the interference pattern we got with light.
Exactly.
Rather than having two bands of spots where the atoms have gone through the two slits, it's as though the atoms have gone through the slits behaving like waves. And
so they're behaving, they're bouncing up and down, and you get patterns, and you still get a large accumulation, but it's still a random pattern, and you can explain this. Like, okay, so this one bounces up here and it goes down here, and this one bounces over here and it goes over here. So, I mean, these are explainable results to this point. And then we get into the fun stuff.
And you get interference of the waves, and you get these bands. If we know nothing about atoms or quantum mechanics, you can try and rationalize it and say, well, maybe atoms behave in a very strange way, and only a certain number of them are allowed to all sit together. And so, me and my gang, we're all going to go on this slit. No, sorry, no room for you. You go the next slit above. And by the way, there's this rule that no one can go in between the two bands, but a few naughty atoms do. So there's a bit of a scatter. We don't. there could be some forces between atoms that make them coordinate their actions in a way to give this pattern. That's not mysterious. That's just, we just don't know how atoms do things.
Right.
But we can be clever and we can force the issue. What if we were to not send the atoms all through at once, but send them through one at a time? Leave enough of a gap for the atom to get through to hit the screen. Of course, as I say, some atoms will hit the first screen and not get through, but those that get through will hit the back screen. So let's run the experiment again slowly, and gradually you'll see as the atoms go through, they'll look like they're just randomly arriving on the other side. You keep sending atoms through one at a time, and gradually that same pattern appears. So each atom by itself is somehow contributing its small part to the overall wave-like behavior that we see.
Even if they're isolated.
How does it do it? How does, we know the atom's a tiny localized particle, we can't say it's too.
And we're going to welcome to the show a good friend of mine, Mr. Bry. What's up, buddy?
Hey, everyone. How's it going, Meaty? Sorry I'm a little late.
Oh, no worries, brother. You're right on time. It's when you told me. Did you take your pants off at least?
Not yet.
Oh, damn it. You got like 30 seconds. Go for it.
Okay, going. It's not out. Yeah, it's fine. Thanks. All right, and I had the wife come bring me some drinks. So,
Oh, fantastic.
we Gucci.
Em just wants to see your legs.
That ain't gonna happen.
Mike, actually, a lot of them do. And it's pretty incredible, in my opinion, that with that limited technology, that they could be so damn close. Like, yeah,
Oh, yes, 100%.
there's some things that have to be twisted, or there's some things that we have new ways of measuring, stuff like that. But to be honest, how far they've gotten and how close they were is pretty astonishing, if you ask me. So, what's a lot number? I couldn't even begin to tell you. I don't know. I have a very small subsection, as many in the science field do. So I couldn't even begin to tell you.
Yeah, I think both Mighty and I have completely different subsects of quantum mechanics that we've studied.
Right.
Because yours probably is what, more of the physics portion of it, right?
Yeah. Yep.
Mine was more the intermolecular forces and energy.
Yeah.
Especially like reactions and stuff.
Well, that's essentially what we do eventually. There's several, but yeah, I mean, one is enough for me. A lot of the elements that were I think a lot of the periodic table was filled in that time frame. So to know different elements and different things like that is it's all pretty impressive. So we're in double split. It's double slit experiment.
We'll get the gold tinfoil eventually.
Yeah, we should get there. This guy's very British. So
He is very British. I've been hearing him.
So we're as an inspiring surveyor and current track labor, y'all are an inspiration. No, we got what you said. Well, I appreciate that, Red. It's good to see you again too, buddy. Like, I hope you've just been busy. So, what's up, Belandris? So we're in the normal pattern of things. So now we're gonna get into
Small to even see under a microscope. We're firing it at the screen with the two slits. Some moment later, you see a flash of light on the back screen. It's
you want
arrived
blue?
in a localized point. It's not spread itself
Oh,
out.
you can bring yourself in
You
if you
don't
want.
get like a wash of a sort of a faint light across the whole screen. It's a little point. The atom is localized. It's arrived in a certain location. And yet, it somehow seems to have been aware of there being two slits, not one, because it's given rise to this interference pattern. How does one atom do that? Does it split in half? Does it become like a cloud that goes through both? Well, we can try and be even cleverer. What if we were to spy on the atom and see where it goes? We can gently just observe which slit it goes through. So you put a detector just above the upper slit that will flash or beep whenever it sees an atom go through that top slit. Sure enough, you fire the atoms through one at a time. 50% of the time, the detector will beep. The other 50% of the time it doesn't, the assumption being that the atom has gone through the lower slit. But of course, I've been cheeky here. I haven't shown you the results of the experiment. That's what you get.
Same experiment, same exact everything. Nothing's changed. Slit size, nothing's changed. We're still shooting one at a time. Completely different pattern from just the act of observing it, and it's observing it in any fashion. Just observation changes it from that interference pattern to this clean pattern.
And something really cool about this clean pattern is that we actually are able to use it and utilize it to actually relate each of those like wavelengths back, or each of those patterns back into a wave, and then use that wave to identify various molecules and such.
It's pretty well. I don't know if you paid attention to the first one, but the first one was also the same exact experiment. Same exact experiment, different pattern. So there were, I think, 8 lines in the previous one. I didn't count, but same exact experiment. The only thing that changed is the act of observation. The speed, the setup, the slits, everything is exactly the same. The only thing that we added was the observation. It's always been one of those things that's been crazy to me. It's just the act of observation, and not even human observation. Like, there's no interference, there's no electromagnetic interference, it's just the act of observation. So
50% of the time, it beeps, and you see a spot arrive adjacent to the upper slit. The other half of the time, it doesn't beep, but you see a spot arrive at the lower slit. So, yeah, it's picked out the atoms that have gone through the upper slit and not the ones that have gone through. So each atom does go through one slit or the other. But that's a different result to what we had earlier. So here's the last bit of sneakiness that we can play with atoms. Surely now, we're going to get to grips with it. Leave the detector there, but just very quietly go and unplug it. Don't let the atoms know that you're not spying on them. Make them think that you're still detecting them. So, yeah, okay, we're going to run the experiment. Atoms, okay, get ready, one at a time. We're going to be checking on you. All right, so run the experiment again. Now, if you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you. Quantum and
So again, nothing changed. They just unplugged the detector, and it completely changes it. The experiment is entirely different, and the atoms know if they are not being observed. that's insanity. Like that's something that's just absolutely mind blowing. So it. I mean, so I'm assuming, Brian, that you have an explanation for that, right?
Oh yeah, 100%. Well, you see, no, I've got nothing. I can't even think of something witty or stupid. It's just so mind-boggling that it's hard to even kind of understand. Also, because depending on how you like try to view it, it will change. So there's like 3 or 4 different ways that you can actually observe this thing that'll all be different, even though you're technically still observing it in the same manner.
The atoms in your brain are communicating with the atoms in an experiment. See, but that energy's atoms not being excited anymore. Well, nothing has really changed. They're not using just a regular camera that's spitting electromagnetic interference. Like this is a highly, highly technical camera that it just doesn't make a bunch of sense. It's not your run of the mill. That's why I can't reproduce it here. And there's no biased interference because again, it changes. I mean, the camera's still there. Like it's like they know that they're there. And part of this reason is superposition. So fun. Not GoPro Plus. They could be shy. They could be very shy. But how do they know? I mean, absolutely. It's like they know how and where they should go, but nothing has changed at all. And one of the things with science, one of the things is the scientific method, and a process is repeatable. Like if I don't know, if I roll a ball down the hill with a highly, highly advanced triggering system to let this roll down the hill, and then I do that 100 times, I'm going to get the same exact measurement every single time. This is not. This can change, even though it's the same thing, by just watching it. Like if I roll the ball down and I watch it, and then I roll the ball down and don't watch it, it's going to be going the exact same speed, exact same time.
The Wikipedia, specifically for the double slit experiment, has some really trippy images on it. Ones where you can actually... this one is actually just a classical wave optics formulation.
Okay.
It was what was said in the very beginning of the video, where with the sand idea, where you're basically piling it up. But in this one, you can actually see the reason why it reforms as like a wave pattern instead of like these mounds, like how he was describing it.
Okay, we'll go to that in just a second. We're not to quantum entanglement yet. Oh, you can share it if you want, but I'll share.
I ain't smart enough for this crap.
I'll share it.
Oh, the wave functions, orbitals, fun.
So so again, no, that's why I said highly technical experiment where there's no human interaction at all. So this is hydrogen wave function. So this is a hydrogen atom, one of the least complicated. And this is all, you got the wrong formula. So this is all of the wave functions and probability of density. This is where, so we can't directly measure, 1, because it's going fast, 2, because we have no idea, and 3, it changes if we observe it. So we cannot tell at all where this electron is. Yeah. We have no idea. We have probabilities, and we can say it's potentially in one of these density plots, but right?
I'm sorry, what?
We can't tell where anything is.
No,
Yeah.
not necessarily.
Just a probability of where it could be.
Yeah, a extreme probability of, I believe it's h bar over 2 probability, which h bar is just a constant.
But so it's not even that great. I mean, these are the potential wave functions. So this is just where these could be. Could be these.
Yeah, and the probability of it being in a certain function has to do with how many electrons it has.
Yeah, that's what we have, the different numbers. So
yeah, so say there's only one electron, like in hydrogen, you have just the highest probability of it just kind of flying around it just randomly. But then the second one will then cause it to do something slightly different.
And then it just gets more complex as we get into. Yeah. So this is a crazy. So this is the picture that Brian was sharing. So this is the waves and how they're propagating, and kind of reflecting off themselves. So that's the first one, and how it's acting on the back.
Yeah, and if you look on the far right side of it, how you can like see that one spot will hit, and then like this, like right next to it, another spot would hit. That is, it kind of looks like two hands kind of maybe tapping on a table, like not simultaneously but alternating.
Mm-hmm.
That each one where like it's hitting the base would be where it's like where the wave is at its lowest, and the other part next to it will be at its highest. So you can actually see the kind of wave forming on the far end. So if you take a picture, like a still shot of it, it will look like a wave on the far right side, even though it kind of looks like it's just spasming out for us.
Right. And that's observable. That's something it can measure, and something that we can predict. The other one just isn't. So we can now, as we know, observing it. But here's the math if anybody wants it. Well, nope, shit, that's uncertainty. Sorry. No, don't read anything about uncertainty.
It'll confuse you.
We'll get into that next week. There we go. See, it has. I wonder if we should just roll into uncertainty as well.
It might be kind of for the maybe.
Now you sound like a quantum physicist. It might be kind of for the maybe.
Yeah, S, P, and D, as you can see right here. So those are different orbitals that he's hovering over. So the S orbital is the kind of the first kind of ring that an electron can make. The P is like the second kind of set, and the D is like the third kind of set. Like D orbitals, you can only necessarily really find them in like metals that have like a certain number of electrons. They won't necessarily be populated. It's like kind of like a school bus, where you can only have like, so say you try to like load the front half of the school bus first, you have to have so many electrons in order to get to the back. And that's kind of what happens here. They try to populate kind of going as they go. So you can't fill the back of the bus before you start filling the front of the bus.
Mm-hmm.
So
it's a progression.
It is a progression system, yeah. So you go from S to P, then to D, and then I think it's G.
Yeah, I think it's G, yeah.
You just kind of start going, and then as soon as you get to the D orbitals, so I don't particularly like the picture that it shows here. because that's a very specific d orbital. You normally start with something that kind of looks like a four-leaf clover, actually.
Well, we can.
Yeah, the one that's 3-2-1.
3-2 and 3-2-1.
You normally will end up with that one kind of first. 3-2-0 is a little funky sometimes, but that is also a d orbital. That's the one that they were showing in that graphic, but I've seen 3-2-1 more readily used.
Yeah, I mean it's more. I don't know. You can use it. It could technically be in either position, just depending.
That's true.
Yeah, I mean both are illustrative of it. This is going to be the 3-2-1 is going to be the more common illustrative because
it's also easier to draw.
Right, it's clean and pretty.
It's very clean and pretty.
So,
but it also, because how molecules interact with each other depends on their orbitals. So like something with an s orbital will probably only interact with another thing with an s or a p. Like it will stick to one of the edges, but so like lobe will affix to lobe, kind of, and that's how you get bonding. The lobe will touch the other lobe and be like, "We're friends now," and then they'll start sharing.
I don't know if you can see my plus. Can you?
Yes, I can.
Okay, so this will attach to this if they're two different.
If they're next to each other, and they'll become essentially one cloud. So then you'll get like a weird conglomeration of cloud in the middle of the two, and then you'll have two nuclei and whatnot, and it won't want to move away from the others because they want to share. The whole analogy of sharing is caring is all about electrons.
Yep.
But you can look at them as a particle because that's how you learn. But they're actually a wave.
Yeah. No, we're not going there yet. So basically, it wants to fill. It's all about filling electron shells and making that bond. So it really wants to be stable. Atoms want to be stable. They want to be stable. They want to be with their friends. They want to just chill and play video games. You know, like that's an atom. When we get like, and I know we're getting a little off track, but when we get like the crazy, like tannerite, when you see those crazy interactions, or sodium and water, or blah blah blah, like yes, that explains it. You're not stable. You're getting it now. So when you start interacting with things like that, it's because they're unstable, and you can come back in 10. It's fine.
Sorry.
We're trying really hard to not make brain hurt, but quantum mechanics makes my brain hurt. God damn it. Jeez.
Oh, I can't click on comments. Dang it. Oh, here's a good image on what I was talking about in terms of they want to share. Is it this one? No. So as you can see how it's kind of lobe to lobe sharing, lobe to lobe sharing. This is a bond. So they will want to share these clouds. That's all I wanted to say.
Okay. One, Digger, it's good to see you, dear. Two, and I'm not saying, like, I'm still thinking this. It's not going to make a difference because we're gonna tear it all apart in 10 minutes anyways. So
we're gonna set it on fire and throw it out to sea.
And it's just kind of one of those things. So here's I believe what Deez is talking about here. It's gonna be a bitch to get everything on. But here's your stability, and you're filling electron shells. And then when you start mixing things, so if we have hydrogen and then we add its friend, oxygen. Where's oxygen? like they work well together. Because hydrogen just wants to sneak in and be friends.
I think this might be the easiest way to show this.
This is not theoretical anymore. This is pretty well settled. Although fucking confusing, it's pretty well settled.
I think this might be the best way to explain it. So what I'm showing right here is it's argon. Argon has 1, 2, 3, 4, 5, 6. A lot of electrons. Each of those half arrows symbolizes 1 electron, right? So 1 electron is going to have a counterclockwise rotation. The other one's going to have a counterclockwise rotation. We're just going to say that for simplicity's sake.
Oh shit.
Each of those boxes can hold 2 electrons. So the s orbital can hold only 2, where the p orbital will hold 6. And it wants to fill up each one of those boxes. If there's a box that has only 1 arrow or half arrow in it, it is unstable and it is not happy. It will want to fill that last bit up, at least so it has, at least every friend has a pair. But the thing is you don't fill it, like, so say we go to the 2p, you fill them one at a time. So 1 in the left, 1 in the middle, 1 in the right, and then you go the second one on the left, the second one in the middle, and the second one on the right.
And this is why I don't do chemistry.
Yeah, and it most of the time will go 1 to 2 to 3, unless you start going into other things. But that's energy. We don't need to know that. That's not important right now. All I'm trying to say is it wants to try to fill up as many of these boxes as it can. And if any of these arrows are missing or they don't have their buddy, they're very angry and then they start to explode.
Mm-hmm.
A good example of this is sodium. Sodium, everybody knows as soon as it touches water, it explodes. It is missing its most crucial friend in one of the most crucial boxes, so it will explode. It is like that weird bipolar girlfriend.
See, we got 1 on the top, but not on the bottom. In that outer shell.
Lithium is worse.
Lithium's pretty bad, yeah, because it's much easier to break apart, and because it's not as complex, and blah blah blah.
That's why lithium-ion batteries explode.
Yep. Potassium, same way. We have this outer shell that's not complete. I didn't know rubidium was reactive.
You didn't know that? Oh no,
I actually didn't.
It's less reactive, but it's still reactive.
Cesium, obviously. Cesium's fun. I love cesium. But so all these group 1s are reactive. So
yeah, and they become less reactive as you go kind of down the line. Pretty much. Sort of.
Hang on 1 second, Brian.
Digger, EVs are safe as long as you don't mix the cords up. Yeah. Like what was that massive explosion that happened on a dock recently where they were housing a whole bunch of fertilizer and used car batteries? Yeah, that exploded. Huge explosion. Yeah, lithium batteries, they're not great to like break because lithium is rather explosive. The whole battery thing is trying to keep the 2 parts separate and say you can react sorta. Oh, it's like going to jail. Like you want to keep the inmate away from his girlfriend so they don't make a weird jailhouse baby. But
no, it's more like edging. You're like, you don't get to come yet. Like you're gonna have to wait.
Yeah, you're gonna have to wait, and you're gonna get built up, and then
Yeah.
Slowly released because you get blowed.
Slowly discharge. And then let us use it. So here's a breakdown. We have alkaline earth metals, alkaline metals, metalloids, nonmetals, poor metals, transition metals, lanthanides, actinides, noble gases, halogens, and I think that's all of them. So when we look at when we look at something,
Go to neon.
yeah,
Go
I
to
know. I was
neon.
trying to see.
It's
Oh, they have
scroll up.
moscovium on there.
Oh, really?
Even though it hasn't been synthesized yet, right?
I think it did for like 3 trillionths of a second.
Oh, okay.
I think that's one of the ones that was made.
I thought 115 the one that we haven't gotten yet, but neon. Look at neon. Neon is very happy. It's got this outer protective shell that's really great, and then it's got this inner protective shell that's all nice and happy, and it is very well. And then you take its buddy argon. Look at how nicely argon's paired up and
They all got their battle buddies. No one's getting cucked.
protected. Like this is like a fucking castle fortress right here. You're not getting to this R. Same thing when we get
Moscovium was made in
into...
2003 by a Russian-American team.
No shit. Okay. Oganasan.
Yeah, you start getting some just absolutely dumb stuff. Radon. That's the stuff you find in your basement, right?
Yeah. Yep. Xenon. Xenon's pretty non-reactive. So all these ones with their battle buddies and their pairs are going to be really non-reactive unless you start doing weird shit to them.
You have to pump so much energy into them. It's not even worth it.
We're not talking about chemistry here.
Sorry.
No, that's fine. I mean, that's why I brought you over here because, well, and then so you have chemically active elements like bromine that can make some pretty nasty shit.
Yeah. So when you start going to the other side, so it's either you have one cookie and you really, really, really want to give it away, or you're missing a toenail and you're really wanting to get one back.
Yeah.
Because it's like, ow, it hurts and I want my toenail back. And it will violently react. And actually, as you go across the periodic table, if you go to the very top, to the very far left, it is the most reactive, and to the very far right, minus the noble gases, you're in the most reactive. So hydrogen fluoride is one of those acids, because anything that's like an H plus and then anything else. So like
hydrofluoric
acid, yeah, is so reactive it will eat through glass. Every other acid can be just perfectly fine, except for I think one, which I can't remember off the top of my head which one it is. I think it might be sulfuric. It can be in glass, except HF will eat through the glass so fast and then explode in air.
Yeah.
It's bad. You do not want to mess with that. We do not mess with that.
I can't say this word, but fluoroanionic acid. Do you have any of that?
No, absolutely.
If not, can you get some?
No, I don't. I think that might actually be a regulated thing.
Oh yeah, it is.
Like
tetrafluoroethylene.
I'm on lists just because I bought iodine.
HSBF. So hydrogen SB is sulfur?
I'm sorry, one more time.
SB?
SB is not sulfur.
No, it's
S
not.
is sulfur.
Yeah, SB. What? It's not. Again, this is why I don't do chemistry. So many fucking just write it out. Antimony. Okay, that makes sense.
It's one of the weird ones. I was like, what is SB?
Yeah,
it's one of the weird ones. Element 51.
So hydrogen antimony fluoride is. Then you get into the. So it's hydrogen fluoride and antimony pentafluoride. I kind of just fucking read. That shit's some gross, nasty, horrible stuff.
Yeah. And if we go back to the transition metals, those are the only ones with the 4-leaf clover that I was talking about earlier. Those are the only ones that ever actually get populated with that d orbital. So the 4-leaf clover.
Yeah.
So you're looking at your iron and your copper, cobalt, all your metals.
Yeah. Scandium, yttrium, zirconium's cool.
Chromium. Ooh. Chromium's nice. You plate your cars in it.
Yeah.
Tungsten. Get your wedding ring that you need to you can't take off with diamond.
Tungsten is ridiculous. Oh, I got some half name the other day.
Oh, really?
Yeah. I'll show you later.
Wait. Yeah, please do. Did you get it in the block form that you can use as a paperweight?
No.
Damn.
Do you want some? I'll put it in an acrylic block. Well, you could probably put it in an acrylic block.
I have so much acrylic. You don't need to be giving me that, buddy. Digger, tungsten rings, you break your finger. Oh, no. All you guys out there, stick with the normal shit. That's my only advice. If you start going with tungsten, you break your finger. If they can't get the tungsten off, you're losing the finger.
Yep. What the hell else did I just get? I got something else too. I don't know. We'll talk about it.
I want to get some osmium just because I want it.
Just because you want it.
It's pretty damn cheap, but it's one of my favorites.
Okay.
I've worked too much with cobalt.
Tungsten's really cool. I have some tungsten, but not.
Maybe I'll ask Digger for some.
Yeah. Are you trying to be the next one?
Maybe.
I was looking for something specific.
What are you looking for?
Cobalt.
Cobalt is on the right side, a little up.
Is it? I thought it was transition metal. It's not.
It is a transition metal. I think it's like a mix.
I'm not seeing it. God
damn
it.
27.
Oh, there we go. You said it was on the right, you dick.
It is in the right. It's kind of the right middle.
No, it's right in the middle.
Is it?
No. Okay, you're right. I'm sorry.
Cobalt's beautiful. The way that it interacts with energy is weird because it both will go from blue to red. I love it. It's also super toxic. Don't eat it.
Yes. I mean, don't eat anything, but...
Disagree. Food is necessary.
Well, I mean... Shit, I don't think it's... Don't eat any pure elements. Like, you can eat food.
You can eat carbon. Go eat some graphite, kids. It's good for your bones.
Carbon tet?
Don't actually eat carbon. It's not great. It doesn't taste good. Graphite tastes like shit.
It does. Fuck, where did I put that?
Digger, if you're happy to send me one of those rings, I will straight up use it as my own wedding ring. Legit. I don't know if I can get the thing fucking resized because I got small ass fucking black hands.
People have small hands? Wow, that's something I didn't know. Anyways, yes. So they say that the reason I brought up cobalt is the next supposed step in destroying the world will be cobalt cobalt nukes. So, like a cobalt nuke would be fucking devastating. It's a size 8.
Digger, I'm a size 8. Give it. You got small hands too, buddy. Shit.
You sent me all right. Oh shit, I have it up. Appreciate you, sir. Here's JSD's nuts coming in. All right. The other one is 7 rubies, my birthstone. Oh.
Oh, this is fucking hard to read.
Yeah, but we can look at it. So here's hydrogen. This one's nice. I'm going to keep this one. So we have boiling, freezing, structures, all that kind of stuff. Lithium. Can't you eat lithium?
Can you eat lithium?
No, you don't want to eat lithium.
I actually think they have lithium salts that you have to eat.
Well, yeah, lithium salts are for crazies.
Yeah.
Yeah. Hydrogen is fun to burn.
Nickel is fun to burn.
Oh shit! This has all the constants in it too, and everything.
Oh, those are nice. Planck's
Oh.
constant 6.62616. God damn it. 6.626 times 10 to the negative 34th. You fucking get rid of those last 3. Those are useless.
But maybe one day.
No. The most useful is Avogadro.
Fuck, where did I just put that? I was going to send it to you. Oh, there we go. Oh, it's a PDF. That's why. Okay. Deez, why are we not friends? There you go. We are now. God damn it. I'm trying to. Okay, why I'm dicking around, because I obviously can't do anything because I'm retarded. Brian has a new channel over on the Rumbles, and he's doing great things. Shower with Your Dad Simulator. Is that the most recent upload?
Oh, yeah. Shower with Your Dad Simulator is the most recent. I should have another episode of Mini Healer coming out soon. I have 100% am going to be doing as long as it's active and like online. I will be playing the early release of Diablo 4. I will hopefully be live streaming that one for like 3 days straight.
Friday?
So,
Is it
Friday? Yeah, I took off work on Friday, so I can play this game.
Okay.
I'm excited. So I will be on all day that Friday.
Wait a minute, though. Okay, so sorry, we're kind of getting off topic, but it's okay. It's me. So you never played 2, so you only played 3, correct?
I played quite a bit of 3, yes.
Okay, so you don't know what's good for you, and it's going to be shit.
I don't know what's good for me. That's the best part.
You don't, because Diablo 2 was probably the best. Diablo 2 is what got me into gaming originally. So, God, that shit was so much time into it. So,
well, we'll see what happens, because I'm expecting it to be pretty decent.
Yeah, I mean,
compared to like other games that are currently coming out, I expect it to be finished. Kinda.
It's not gonna be.
I know. I can hope.
It's especially not gonna be an early release. Jesus.
Oh yeah, it's gonna be a shit show. But that's why you're all gonna join me. And the more alcohol I drink, the better it'll feel.
That's true. Do you have enough to live stream? You have your 25, right?
I think I can live stream without the 25 because it gives me the option. I think I might be wrong, but if I can get to 25 before then, that would be amazing, everyone. If you can quickly subscribe to my Rumble channel, so I might be able to subscribe, might be able to stream. That'd be great.
You 100% are not able to stream. You can pay to stream, but
then I'm screwed.
So you can pay to stream, or you have to have 25. So get over there, mods. Can you drop Bry's link for me, please? Because Bry's a good guy. I think. Probably not.
Good enough.
I mean, He's cute.
That is true. I am pretty cute.
Pretty cute. Very cute. Anyways, back to this shit show. So I've decided that we're just gonna finish up on this first portion because I think my brain will hurt if we go into the next portion before. I think it's better to do it. Like better to tell them everything.
Knowing where
and
things
then-
are better than not knowing where they are.
Correct. We could do. You know what we could do? Shit. No, that gets into. Well, Schrodinger's cat. Like I don't feel like wasting a whole episode on Schrodinger's cat because it's already been.
Schrodinger's cat is literally 99% of what we're going into next.
I know.
We can do what we're doing next and then go into energy.
I don't want to though, because then we're gonna confuse the shit out of people. So
that's 100% gonna happen.
Well, I know, but I'd rather confuse them next week. So when they come back, so they can get confused.
Oh, that's true. That's true.
That's very true. We might just do a shorter show and kind of recap, if you're cool with that.
100%. I'm cool with everything. I'm one of those easy girls, you know.
Yeah, you are. Do you get? Yes, I'm sure you do. So basically, what we got is that wasn't being a dick. I'm sure, like Schrodinger's cat is like the concept itself is okay, but when you get into more depth of it,
once you apply it, it's bad. It's really bad. You have to just drop everything you know about reality.
Yeah. I'm crazy.
I'm sure a schizo came up with it.
Sorry, Brian, I was AFK. Fuck. All right.
Ambish, it's okay. I love you. Thank you for posting the full length doohickey thing that you had sent me before, and I completely forgot to open.
Oh, there we go. There's his link. You're a great guy. So with that, we are kind of getting into it's like I said to begin the show, like it is simplistic, but it is also incredibly confusing. So it's simplistic. We don't know where anything is. It changes when we observe, and we really have no idea how it acts. There's no way in hell we can measure how fast an electron's moving. No way. I mean, we can't even find
no
a damn
exact
thing.
way.
There's not even approximate. I mean, like you can approximate it, but there's not even really an approximate.
It's such
way.
a bad approximate. It doesn't even matter.
That's what I'm saying. Like there isn't even really an approximate way to measure it. Like it is just it. It's when you get into quantum, and there's so much of this that hasn't been sussed out yet, or hasn't been gone through, or hasn't been, what's the word I'm looking for? That hasn't been through the scientific process. And that's something where certain people would be like, oh, well, shit, you just don't know what the hell you're doing, or it's this or it's that. And trust me, there are a lot of very intelligent people. See, and I don't agree that it's alchemy. I assume you wouldn't either, correct? Or
define alchemy. Because I mean, in the past, alchemy was just a guy throwing a whole bunch of magnesium into fire and figuring out why it's so damn bright. Now we use flashbangs.
That's true. String theory has been significantly disproven. String theory, somebody cut the strings and it's gone.
It was like a
Correct?
guitar. Now it's just a bludgeon.
I just wanted to make sure. But yes. Yeah. String theory has been given to the cat. So
But it is cool to think about if it was like actually like existent. It's a really cool plot point for shows and stuff.
Yeah, I could see that. But yeah, so I mean, again, these are concepts, and I think that's best to not confuse the shit out of everybody even more. You know, we'll go into the next one next week, and we'll keep moving along. Maybe next week. Well, next week I think we can do both. Shit, where's my book? Next week I think we can do uncertainty and Schrodinger's, because I think those go hand in hand better, right?
Schrodinger's equation.
Yeah. Cat and equation and uncertainty. Yes, no?
I think so. It should be okay.
Okay.
They do hand in hand significantly better
Than this and anything else.
Yeah, like if you said like, let's go into what's that called? My brain stopped immediately as you said, "Can we do this next week?" And I was like, "No, maybe not." The guy that I mentioned really early in the stream, who did I mention? It's energy. Fuck energy. We ain't doing energy yet.
No, because quantum field theory is mine, and we're not there yet.
Yeah, no, we're not doing that yet.
And quantum entanglement. So I figured we'd do it that way, and then quantum field theory and quantum entanglement we'd do together. And we could talk about it. We can make it make sense. But Jesus Christ, my head hurts. This is a topic that makes my head hurt.
This is a topic that is when you're going through chemistry as a degree, you do this in your senior year, and it actually causes people to drop out in their senior year.
In their senior year, yeah. Yep.
It is
same in the physics side. So. Oh shit, that's cool too, D's. Let's do this. We can burn some time doing this. I mean, provide some content.
Burn some time, provide content. What's the difference?
Yeah.
We're helping people sleep at night, knowing that, nothing. They feel like they know nothing. I feel like I know nothing. Holy crap. I feel so stupid looking at some of this stuff sometimes.
Well, and that's the bitch about it. Like you know what it is, but to explain it is just impossible. It's nearly impossible. Okay, so here is yeah, I saw it, buddy.
Oh, fucking Bohr. We're not messing with Bohr, right?
No, God, I hope not. Not yet. Yeah, the test is why. It's just
the test will be how hard can you hit your head against a wall.
And this is okay.
That's what
again,
this feels like.
I know some very intelligent people with fuck tons of degrees, and they are doing the same thing. Like, fucking why? Because this doesn't go. This doesn't. I think the biggest part of this is we have somewhat of an understanding. Yes, please, Digger. We have somewhat of an understanding of the way that our natural world works, the world we can see, interact with, that kind of thing. And then when you get down to the quantum level and to the atomic level, we have no idea.
We used to think that molecules were fucking figgy pudding.
See, he can't even talk anymore. That's how mushy figgy pudding atomic his brain is.
Yeah, 100%. Like, we used to think that electrons floated. Now we're like, oh, now it's in the shape of a 4-leaf clover. This is great. No, we're going to be wrong. Give us like another 50 years. It's going to be screwed up, turned upside down, and it's going to be dead.
Okay, so D sent me this, so we're gonna make it. So we got a proton or a neutron. Shit, I already screwed up. A proton. Oh, we have a stable hydrogen. This is really cool. So now we're neutral. Negative ion of hydrogen. Now we're an unstable hydrogen. And why is that? Because his neutron doesn't have a friend and wants to leave. Do that. And then stable helium. And then we can change. If we put this guy up here, negative ion. Shit, that's not where I wanted to put it. Come on. So now we're still, we're still stable. We're still negative.
That's because you don't have enough protons.
I know. Now we're unstable helium.
I like how it shakes.
I know. 3 protons and a neutron. I don't know. Let's try it. Unstable lithium.
That is definitely some kind of like lithium radioactive bullshit.
A 4th one would be sodium.
Beryllium.
Oh, beryllium. Okay, yeah.
Highly unstable beryllium, but beryllium. Then we go to boron, carbon, nitrogen.
Can carbon be unstable?
Yes, abso-fucking-lutely.
Really?
We're actually able to shove. So normally with carbon, you can only get 4 bonds off of it. We've been able to get a 5th.
Oh.
And it broke apart almost immediately. Like, very quickly, it decided it hated life and died.
So now we have an unstable neon, which is an oxymoron if I've ever heard it. But...
Is this only able to go up to neon? Can you grab any more protons out of the bucket?
No. Why could I not? Why can I not go further?
Oh, that's so sad.
I know, that's what I'm saying. Maybe when I make it stable. Why do I have more neutrons though?
Because you can get some weird isotopes of
what? But why wouldn't I have more protons to make heavier elements and not have? So now we have stable neon.
It'll be stable until you get, I think, at least all of these on. Yeah. So this is when you get radioactivity.
There we go. There's clouds.
It hates everything. It hates having all those extra neutrons, and it will expel them at very high speed. And the speed it expels them at is actually enough to damage the atoms in your skin, which is where radiation poisoning comes from.
I can't change any of that. Like, I can only add...
The question is, if you start taking away, if you actually do, like, the proper cloud, will it actually do, like, the proper orbitals to it, too? Or will it just be, like, a freaking circle?
I don't know.
I'm just curious about that.
No, it's just this cloud, so...
Because, like, I mean, but it has full orbitals, thus it should be kind of like a circle.
No, it's not.
I
it's
know.
Not changing anything.
Oh, that's big sad. Because, I mean, that's kind of true, but it's not. Ooh, a guessing game.
Find the element. Hydrogen? No.
Yeah. Yes. Yes, it's hydrogen.
That's what. Why are you fucking with me then?
Is it neutral? That's the question. Yes.
See, now I feel like you're just being a dick.
Oh, I am. You're wrong.
I don't like it.
6 protons, so count to 6. 1, 2, 3, 4.
Carbon.
God damn it, it's carbon. 7 neutrons with 6 electrons. Is that
No, it's nitrogen, right?
1, 2, 3, 4, 5, 6 carbon. Nitrogen 7. That's why there's carbon 6 dating.
Okay, you're right. God damn it.
It's neutral. It's an isotope, but it's neutral. We're looking at oxygen. Highly charged oxygen. I'm good at this game. This is hydronium. It's not an ion. It just has
God
no...
damn it. You said fucking hydronium, and then I got...
That doesn't mean it's an ion. It's actually... Hydronium is water. Deuterium?
I'm trying so hard to not listen to you, but you're in my brain now.
It's deuterium. Anywho, it's also a D. The H just randomly can turn to a D, guys. Do not worry. What?
It's not an ion?
Helium? There's 2 protons.
Oh, it is helium. Okay. Then why the fuck did you say...
What? I was talking about hydrogen can also be called deuterium. I was talking about that.
Oh.
Magnesium. It's beautiful.
What?
What are we trying to do here?
We got to change this number, baby.
To what? A charge? It's a fucking +2. Yeah.
Right?
Uh-oh. H.
I can't get H, though.
Then it's a 1.
Oh, there we go.
You can count.
Jesus Christ.
I can't. 1, 2, 3, 5. Shit.
1?
No. Wait. Oh, yeah, no. 2.
See, I don't trust you at all now. Okay.
Trust me.
I don't.
This was how my friends would test to see if I was too drunk. They would, start quizzing me about the periodic table, and if I couldn't get it right, then they would say I was too drunk. I would overdrink every single time.
I'm surprised by that.
17 plus 18. I don't know how... I can't math. So... The thing I really dislike about the periodic table is we have proven that electrons have mass to them, except it's not enough to make it matter in terms of the periodic table.
You didn't say shit there, and I got it right.
Say what?
You didn't say shit there, and I got it right. See?
Good job. I don't even know what the last one was.
I don't know.
Ooh. See if you can do it. See if you can do it.
Come on.
See if you can properly fill these orbitals. Let's go. Notice how he didn't go into the second one. That second orbital is this. It would not get filled until the first one's filled.
Yep.
Did they just give you the same thing again, except without a neutron? Or 2 neutrons? Wait, what are you doing?
Oh, shit. What am I doing?
Those are electrons, my dude.
I know.
They're weightless in terms of the periodic table. You get a 1 there.
No.
And it's a -1.
I'm working on it. There we go.
Who just joined? Jacob, what's up, buddy? We're testing Meaty's chemistry skills.
No. Brian is fucking with me.
You know all about silicon, right? There you go. You knew it. Argon. Let's go. $1820.
Shit.
Charge is 0.
But there's 18 electrons.
18 electrons.
Dick.
What? Nothing was wrong about what I said.
+1, but 1.
What? Yeah.
I thought that was harder than it.
Yeah, you
Anyway.
almost got tricked by your own self. That shit was loud.
It was very loud. But
It's exceptionally loud.
I use this one, another, and a few other simulations like this one in college. Yeah, no, I think it's fun to mess around with, but with Brian, it makes it suck. So
I can make it worse. You want me to make it worse?
I do not. I'm not. Oh, we didn't play the charge game.
Oh,
Why
we
didn't
didn't play
do
the
the
chart.
charge
Wait,
one?
how do we only have 3 stars in the first one? We gotta fix this.
It's total charge -1.
-1.
I just took my headphones out, so I can't hear you because you're gonna fuck with me. -1.
7. Shit. Maybe you did. Oh, that's dumb. You can't go down. Are they fucking with you? Oh, good.
Bitch.
I couldn't read.
Take care, Digger.
Later, Digger. Oh, it's gonna trip him up. It didn't. He's good.
Okay, headphones back in. See? Perfect 5 stars.
Yeah,
Now
good
you're
job,
gonna
buddy.
fuck me up again.
Hydrogen.
Hydrogen.
Ion.
Ion.
Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Fluorine.
Fluorine.
Neutral.
Nitrogen. Definitely ionic.
God damn it. There we go.
2 plus 2
Helium?
is... Yep,
And it's neutral.
definitely.
Boron?
1, 2, 3, 4. Yes.
And it's neutral.
Definitely neutral.
Oh,
Oh, good job, buddy. Yeah.
we got it.
Woo! Science night.
Now we can go to bed happy.
This is my bread and butter. This is literally... I cannot tell you the last time I've seen an orbital. Everything I get is some kind of random bullshit, like upper management wants you to test this bullshit. I'm like, fuck you, upper management. I do what I want, and then I end up doing it anyway because I want to do their bidding.
Yeah, you gotta.
I'm a good yes man.
Argon,
Gargle?
you can suck on argon, but you gotta watch out. If you have breathing problems, don't do it because it can be dangerous.
Oh yeah, it could fuck you up.
It sits in your lungs. So
It's very heavy. It's hard to expel.
why did you write it in the third person, you fat?
Because I copy and pasted exactly what Impish did.
Oh, okay.
Also, I am a third person. It's the other voice in my head that tells me to do this channel. I should get on some lithium.
Brian, for you.
I see the yellow orange box thingamajig. I'll probably hit you up. Ugh.
So, ladies and gentlemen, thank you so much for stopping by for our TED Talk. That was terrible. Like I said, it's not that complex.
Until it is.
Yeah, go for it. That's even more dangerous though.
See, the concepts aren't bad. The math is terrible.
Oh, the math is horrific.
The math
Right.
kept me up till 2 a.m. most nights.
We can't do math on this channel because then everybody gets intimidated and upset.
Everyone will leave. We will have like 6 pages of math.
Yeah. Weeks of math.
Oh God. No more weeks. No more math.
But we get more into my realm as we go later. I want you to take everything that you learned from the show and throw it out the window next to you, because the next one is going to contradict everything we just fucking said, but it makes sense. Hopefully.
If you throw out the stuff that you just learned, it'll make sense.
Right. So, as always, thanks, Brian, for joining me. Brian, I think, is going to try and be more of a regular on Wednesdays, right?
Yeah, I'll do my best.
Yeah. So he'll keep working with me on stuff like this. It was good to have the chemistry brain here, because fuck chemistry. Jesus, I hate chemistry. But
God, I love chemistry.
Oh, I hate chemistry. So close, but yet so far. If you haven't yet, please go subscribe to Brian. He's an awesome guy, great friend of the channel, great friend of mine, and he won't steer you wrong. He plays some good games over there.
I'll be playing better ones, more mainstream stuff, hopefully.
Yeah.
If you have any suggestions, hit me up on Discord, on Mighty Meats Discord, over in the gaming channel. I will definitely be looking at that a lot.
Chemicals just in general explode if you don't know what the hell you're doing.
Oh, 100%.
So,
we had a fire at work, actually. Someone decided that they wanted to shove a whole bunch of reactive chemicals into sparks.
Oh, that's wonderful.
Oh, yeah, it was great.
But so I'll be hanging out over at Discord. Also want to play this fancy new outro that with some music that somebody made me. It's not yours.
Thank God.
No, it is.
Okay.
So thank you so much for stopping by. Please hit that like. Please hit that subscribe. Like I said, after we get out of the quantum shit, we get into better topics that are closer to fuck. I'm just lying to you. Like, we have quantum for like 2 months. It's ridiculous.
It'll be a while.
So, but we'll try and explain it as well as 2 people can. So, but yeah, thanks for stopping by. I hope everybody has a wonderful evening. Tomorrow is news roundup and movie night, and yeah, and then we'll go from there for the rest of the week. So have a great night, everybody, and we'll see you soon. Bye-bye.